Thank you all for coming for this talk. So, so the title that I was thinking about the title and I thought about this title, that Art and Science of Sanskrit Chandas. And I put art first. So let's start with this. I mean, I think many of you will know this Bhavani Ashtakam sloka. And if any one of you can start chanting this. Okay, just by hearing to this, you should be understanding what a chanda is, right? There is a certain rhythm to this, and this is not accidental. Okay, and so this is called a bhujanga prayata chanda, and we will come to that. But what does the word bhujanga prayata mean? Bhujanga means snake. So it goes like this, not ta, so up down, and an even more extreme example of this is, again, this is a very well-known sloka. Again, someone can volunteer, please.
Jatakata Sabramnini Brahmanilim Panirjari Vilolati Chivalari Virajamani Murdhan Jagat 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 Jala Lalata Patta Pavake Kishora Chandra Shekhari Rati Pratikshanam Mama.
So you see, this is even more up, down, right? And this is called Panchachamra. Okay, so how is this being done? Let's start with that. So Chanda is one of the 6 Vedangas. The 6 Vedangas are Shiksha, Chanda, Vyakaran, Nirukta, Jyotish and Kalpa. Now the word Vedanga, what is Vedanga mean? It's Ved Anga. So if you think of Veda as a Veda Purush, the Vedanga are to protect, to preserve and to sustain Vedic purpose. So these are ancillary studies for Vedas, and Chanda is of the same status of these other things. So we talk about Vyakaran, etc. very highly, and Chandas is of the same status. And if you take this metaphor even further of the Veda Purush, this is considered as the feet on which this thing stands. So this is for stability, balance, etc. So it is the study of meters and prosody, and we all know Sanskrit text is of 2 types, Padya and Gadya, and Chandavadha Padam Padya. So that means anything that has this meter is considered as Padya, otherwise it's just Gadya or just text. And entire Veda, at least the Samhita part of it, is in poetry. So Chanda is a very, very important part for that. Okay. Now also, I think many of you will remember these 2 slokas, partially because of the Chanda. It helps in memorization. It's very hard to remember text, but it's easier, much easier to remember poetry. So that's one of the reasons why it has been put there. And if there is time, we can also see that it can detect errors, and I'll probably elaborate on all of this a little bit later, what does it mean. But more importantly, at least, it improves the aesthetics, so which makes it pleasing to just hear. And many of us have this feeling that even though I do not understand Sanskrit, I like listening to Sanskrit slokas. So that is because of this. Okay. So a little bit of history. Apparently the earliest text, again in hand, that we have, maybe there were texts earlier than that, is the Chanda Sutram of Pingala. And now you realize why our automation system is called Pingala. This is the beginning of binary system and other things. Much like Ashtadhyayi, it seems to be a culmination of things. It is at least 2500 years back. And according to some researchers, this is very interesting, Pingala is brother of Panini. Now, whether that is true or not, I am not going into it, but there are striking similarities between how Chanda Sutra is written and how Ashtadhyayi is written. They are both very short sutras with anubritti, that means words taken, padas taken from the previous sutras, etc. And without commentary, you cannot understand any one of them. So that's the other thing. Then there are a lot of other works all over. So this is minus 1400 from time 0, from time now. Virahamka, then Halayuddha Bhatta has this very famous commentary. It is his commentary that people read to understand Chanda Sutram, otherwise you cannot understand this. Then there is Kedar Bhatta, Hemachandra, and Narayan Pandit is a Narayan Pandit's Ganit Kaumudi and these things has elaborated on this combinatorics aspect, the mathematical aspect, very heavily. It has gone into much more details and sophistication of combinatorics. So let's start from the very beginning, and the combinatorics or the chanda starts from this, that all Sanskrit vowels can be categorized into two classes, Laghu and Guru, based on how much time you take to pronounce it. In Hindi we call it Choti E, Badi E. What is this Choti and Badi? Choti because it takes E and then E. So there is a time of pronunciation. That is exactly what is called Laghu and Guru. So the Laghu takes one matra of time, one time unit. These are 5 of this, A, I, U, Ri, Ri. And the others is A, I, U, Ri, A, I, O, O. Okay. So if you classify this, this is the classification of the vowels. Alright. Now every akshara, so what is akshara? Akshara is roughly a syllable. So akshara is something that ends in a vowel or a halanta. So for example, if I write down this word aksharam, it has got 3 aksharas. It's essentially 3 times you have to make an effort to pronounce it. So aksharam. So the mahalanta is part of the ram. So now you see, once I have this, now I can classify each akshara using this to Laghu and Guru. Okay. So here is the classification. So any akshara that ends with a Guru varna is Guru. So if it ends with this A, I, U, A, I, this is Guru. Any akshara that ends with this Anuswar and Visarga, they are also Guru. Any akshara followed by a conjunct consonant, Yukta akshara, is also Guru. So when I say, let's say aksharam, the A itself is Laghu, but it is followed by a conjunct consonant. Then it turns to Guru. So you may be wondering why. This seems arbitrary, right? But you see, try pronouncing aksharam. You actually don't stop at A and you don't start pronouncing kaksharam together. You actually say ak and then. So there is a part of the conjunct consonant that is pronounced together. That's why it is made Guru. So this is very much scientific, etc. So these are the 3 rules for making it Guru. Everything else is Laghu. Okay. So essentially a Laghu is ending in a Laghu varna and not followed by a conjunct consonant. Fair enough? And Laghu akshara is denoted, this is just the symbol, you have to just remember this, that's all. But, and varna, sometimes the word varna is used in Chanda Sutra, etc. But this is akshara, interchangeably with akshara in this context. Okay, now let's try to see the Laghu Guru marking of this, the first line of the first sloka. So, na tato, na mata, na bandhur, na data. So the first one, na, is a simple A without any conjunct following it. So this is Laghu. Then the second one is A. So this is Guru. Second is To, which is again Guru. Then Laghu, Guru, Guru, Laghu, then Guru. This is Guru because although this is Ba, but it follows. So this is Guru. So now you see the pattern. So Laghu, Guru, Guru, Laghu, Guru, Guru, Laghu, Guru, Guru. Now try pronouncing it in your mind. Na tato, na mata. So it is, this is the science, this is the art of this. Right? Here, start with Laghu, then Guru, Laghu, Guru, Laghu, Guru, Laghu. This is Laghu. Why? This is by itself a conjunct, but it's okay. It ends with Guru, Laghu, Guru. So Jata, Kata, Hasam, this is up, down, right? So this is what Chanda is. Okay? We have a website. So for this, just if you just remember this, the rest of all you can find it out. You can try putting any Sanskrit kavya, any Sanskrit sloka, etc. It will tell you what the chanda is. It will also tell you why that is the chanda. More importantly, like I said, this is Bhujanga Prayata. Why this is Bhujanga Prayata? Because Bhujanga Prayata has this exactly the same signature. That Laghu Guru Guru, Laghu Guru Guru, Laghu Guru Guru, and exactly 12 aksharas, pada. We will come to that. Okay. So this is just, you can see this. Okay. And just let me not spend time on this. So the other thing, one is this akshara, the other thing is matra. I started by saying Laghu takes one matra and Guru takes two matras. So this entire thing is how much time you take to pronounce. That is called matra. So now the total time of a sloka is that you add up all the matras. So again, if I go back to this jata kataho, so this is, although there are 16 letters, 16 aksharan, but if you add up the matras, that becomes 24. Okay. Similarly, here there are 12 letters, but it adds up to 20 matra. Okay. So 20 matra is the time that it takes. So 20 time units it should be taking to pronounce this. Okay. All right. So this we have done. We know and understand this now. And okay. So each chanda, therefore, okay. By the way, chandas I have been using chandas, and chandas is the pratipadikam. So chandas is thus defined as a pattern, a regular expression pattern of laghu guru. So chanda again can be of two types. One can be a varna chanda or a matra chanda, but it is a pattern, and each chanda has a fixed length. Also, chanda names are inspired from nature. We saw Bhujanga Prayata, we saw Panchachamara, there will be Mandakranta, there will be Shardul Vikridita, and all of these are all the names you have to give to these patterns, right? And these are again poetic names. And typically each chanda is suitable for a particular situation or a rasa. So Mandakranta, what does the word Mandakranta mean? Mandakranta, slow moving. Why? When do you use slow moving in a poetry? When it is something of pathos, right? So Kalidas uses it very naturally, very beautifully in Meghadutam, right? When this Yaksha is under Viraha ras, so he is sad. So he is uttering in this Mandakranta chanda. There, if you use this Jata Kataho thing, it doesn't sound right. Jata Kataho gives you energy, right? It feels like I'm doing something. Not when you are in undersorrow. So of course, I mean, there is no hard and fast rule, but you see that there is a meaning to each chanda. And then there is a rasa for each chanda. And, sorry, this should be a sloka has typically 4 pada. I'm very sorry, this is a typo. A sloka has 4 pada, quarters. Pada is quarters. So a full sloka, if you take, has got 4 parts to it. Very simple. And the vritta denotes a pattern. So for example, the Bhujanga Prayata is that this is a pattern, this is repeated 4 times. So each of the quarters of the chanda will have this pattern. Laghu Guru Guru, Laghu Guru Guru, 4 times. So each one of them, right? Okay? And Panchachamara is this. Alright. Now, in a sloka, what happens is, again this is sloka. So, in a sloka, what you can do is that you can say this is a samabritya. Sama meaning same. So, all the 4 quarters of it should have the same regular expression, same pattern. Or you can say this is artha samabritya. So, the first and third are same, but that is not the same with second and fourth. You can change it. Or you can have the most generic thing, vishamabritya. You can have. And then there are again beautiful examples of all of them. Okay? But let's for this talk at least let's just focus on the samavritta because it's easier to understand and so basically by assuming samavritta you take out these 4 and you're just worried about this first pada. Whatever happens for the first pada happens for all the 4 padas. Okay. So as I said, chanda can be defined by both pattern of akshara, then it is called a vritta or akshara chandam, or it can be by a pattern of matra, then it is called jati or matra chandam. Okay. And jati has specific patterns of matra. So that means a jati, when you say jati, it has to have a specific matra length. So I want to say that this pada has got, the total matra is 20. Now I am not saying which one is laghu or guru. How can you fill up 20? You can use 10 guru or you can use 20 laghu or any combination of this. So you already see why the combinatorics is important. So Pingala asked this question that if I have this matra or if I have this, how many possibilities are there? I want to fill up total 20 with 1 and 2. How many possibilities are there? This is of course a much more advanced question, but we'll have start with the very basic things. So, but even before that, there is something even more interesting. So, Pingala uses a very efficient method. So, when I say what is Bhujanga Prayata, to describe you have to say Lagu Guru Guru, Lagu Guru Guru, you have to keep saying this for every matra, right? What he does is that he uses a triplet of Akshara. So, that means instead of saying Lagu Guru Guru, you give it a name. So, every triplet is given a name. So, that description length actually falls. Correct? You could say why 3, he could have said 10, 4 or 2 or 10, whatever. He thought 3 is a good number and that's about it. 3 meaning there are, so this is called Gana, Akshara Gana, right? So that means there are only 2 to the power 3, 8 possible Gana. And here is the entire definition of them. So when you have Guru, 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 consecutive 3 Guru, that is called a Magana. Then Lagu, 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 Nagana. Then beginning is Guru, the rest is so Bhagana, Yagana, Jagana, Ragana, Sagana, Tagana. And what happens when it does not end in a multiple of 3? Then you require this La and Ga, right? Yeah. Like the 16th thing. You say 5 Gana and 1 Lagu or Guru, whatever. So you have to use this. So essentially this 8 Gana plus the 2 original definitions. Okay? Fine? How will you remember this?
Yamata Rajabhan.
So here is one sloka. If you are good into memorizing, then you can memorize this. Adi Madhya Avasanesu Yarata Yanti Lagham, etc. But it's not so easy. So what you do is a very ingenious method. You just use this. Yamata Raja Bhana Salagam. So let's try to understand what is this Yamata. So the definition is encoded in this. So you want to know the definition of Yagana, right? So you start with Ya. You take the 3 letters. So that is Yamata. What is it? Lagu, Guru, Guru. That is exactly what Yagana is. Ma. So you start with Ma. Ma Tara. So Guru, Guru, Guru. That is Ma. So you see, this is in computer science we use this, right? This is called cyclic coding. So you use, so the total description length. So here, what are you describing? Describing 3 times 8, 24 things. But what is the total length? 10. So you are concising, and this is unambiguous. This exactly gives you. In fact, we are actually describing 10 things. So you are also describing La. In fact, you have forgotten what La is, just Salagam. So the Sa, the last one actually uses Salagam. This gum because it's an Anuswar, it's technically an Anuswar. So that is actually Guru. Right? So if you remember this, then you remember everything up to so far. The entire discussion up to so far, you just one small, basically just 10 letters that you want to remember. Correct? So you see how art and science are coming together. Anyway, so Chanda, so we all know, so first Chanda that comes to your mind is Anushtup. In fact, Anushtup is not a Chanda. It's a class of Chandas. So what is a class of Chandas? So what is being then done is that any length has a, so all Chandas belonging to a particular length is given a class name. So that means, this is, let's say, times 4 for Samabrit. So anything that has got 8 in the first pada and Samabrittu, that means there are total 32 aksharas, is called Anushtup. Okay? So anything that has got, so we saw Bhujanga Prayata, right? That is 12. 12 times 4 is not Bhujanga Prayata, there is a jati name, there is a class name for that. Correct? So Anushtup is a class of these things. But by Anushtup, what we mean is the most popular sloka variety. This is the most popular sloka in Sanskrit. Almost entire Bhagavad Gita and many other things are mostly in this sloka. It has got its own description, etc. That all pada, the 5th akshara must be Lagu, the 6th akshara must be Guru, the odd pada, 7th must be Guru, 7th akshara must be Lagu for the even pada, etc. But, okay, for some of these long long chanda classes, for example 19 akshara, there is a Shardul Vikridita, 19 akshara meaning each pada has 19 akshara. So 19, 19, 19, 19, that's the total slope. So that's 76 akshara means, and within 19 you can give a yati or pause in between. After pada there is a more pause, but between a pada, between a quarter there is a small pause, yati. So Shardul Vikridita says 12-7. And now what does Shardul Vikridita means? Anyone? Any? Shardul is tiger, Vikridita jumping. So apparently this name is from tiger jumping. Tiger first jumps 12, then a smaller one, 7. So you see how ingenious the names are and how the yati is there. Okay? Then Manda Kranta has 4, then a pause, 6, then a pause, then 7, then a pause. I mean, again, this yati is a recommendation, not part of the strict definition per se. But it sounds better. The aesthetics improves if you actually follow this. Okay? And here is a full chart. So it goes from 1 to 26 and anything above that is called Dandakara. So Anushtup is any 8 to 4. We know a Gayatri Chanda. Where is Gayatri Chanda? 6 times 2. Right? 3 shtup. These are very distant. Correct? So the important thing to remember here is that we started off by saying Bhujanga Prayata and Pancha Chamara, these are not there. Of course, they should not be there because this is a class. And Bhujanga Prayata, so within a class, multiple chandas are defined. In fact, Pingala starts by asking this question. So suppose you go back to this. Anushtup, assume Samavritta. How many total chandas are possible? So how many ways can you permute 8? Each of them has got 2 possibilities. Lagu Guru, right? So it's 2 to the power 8, right? He says out of this. So, and you see up to here is 2 to the power 26 if it is Samavritta. If it is Vishamavritta, it's 2 to the power 26 times 4. So of course not all of them are used in Sanskrit literature or they are named, right? So this is a class that is being defined and then some of them are instances. So Bhujanga Prayata is an instance of this Jagati. Why Jagati? If you go back, Jagati is here. And this is Ashti, right? So Panchachamara is an instance of Ashti. It's a particular instance. Why? Because Bhujanga Prayata is not only of length 12, but it has a particular Lagu Guru Guru, Lagu Guru Guru, this pattern. Right? Okay. So, and last one interesting thing is that Bhujanga Prayata, the definitions of the chanda are also very precise and poetic, and they use the same chanda. So, for example, Bhujanga Prayata is defined using this pada or whatever. This just not pada. This is like a sutra. Bhujanga Prayatam Bhavet Yaihi Chaturbhihi. So, this is 2 parts to it. One is if you actually break down the Sandhi Samas, you say that Bhujanga Prayatam definition ye Bhavet Yai Chaturbhihi. So, there are 4 Yagana. What is Yagana? Yamata, right? So this is essentially saying this. Now, what is the total chanda of this? How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is exactly in Bhujanga Prayata chanda. So chanda of Bhujanga Prayata is also Bhujanga Prayata. So the definitions, you see, so we define lot of things without worrying about the arts or aesthetics of it because it's a definition. Here it's both the definition and art. Correct? Panchachamara, Jarau Jarau Jagavidam Vadanti Panchachamaram. If you pronounce it, you already get a feel of this. And if you again Jara Jara, so Ja, then Ja, Ga. Because it's 16, right? So 5 things. Exactly the same. And this is done for all of this. This is not just, this is not a magician's trick that I have just picked these 2. This is for all of the chandas. So to define a chanda, you have to ensure that the definition first follows that chanda. So it's not easy. And then you can only use it. Okay. Alright. So now by that time I think you have got a hint of what is binary system. Laghu and Guru is essentially binary system. Guru is bit 0, Laghu is bit 1. And So Jagati, the class Jagati stands for all binary numbers having 12 bits. Correct? And this is the assumption of Samavritta, of course, modulo that assumption. Otherwise it's 12 times 4, you can say. Okay? Alright. So Bhujanga Prayata is a particular bit encoding of 12 bit, which is this 100, 100, 100, 100. Correct? Okay. Now, let's move to mathematics of it. Now, using this, Pingala asks 6 basic algorithmic questions. Okay, these are called the pratyaya questions of combinatorics. And he gives one algorithm or sometimes multiple algorithms each one. So the first question is, prastara. Given a particular length, enumerate all possible chanda. What does it mean, enumerate? Meaning, suppose I give you 4, you have to give me all the binary encodings up to length 4. So this is now trivial for us, right? 0, 0, 0, 0, 0, 0, doing. Can you give an algorithm actually? Can you write an algorithm for this? You can say I start with 0, 0, 0, 0 and keep adding binary addition, right? Fine. Other than that, can there be an algorithm for this? So he gives an algorithm and we will see this. So this is essentially enumerating all binary numbers of bit length. This is algorithm or the problem 1. Second problem, Nashta. Given a particular rank of a chanda, what is the Laghu Guru pattern? This is decimal to binary conversion, absolutely directly. What does rank of this thing mean? So I give you one 4-bit thing, then I tell you 1001. Now I rank the chandas, right? What is the rank of this? So rank the chandas meaning I start from 0000, 0001, 1001. What is this? This is exactly the decimal number. Right? Correct? So that's the other way around. And if I now say give me the 10th chanda in this class. So Nashta and Uddishta are just opposite of each other. Decimal to binary conversion and binary decimal conversion. Okay? Then we have something called a Laga Kriya or Eka Di Adi Laga Kriya. And you can see, so now I tell you there is a length n, right? So I tell you there is a chanda of length n, length 4. Now length 4 meaning there will be a chanda which is only Guru, 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 Guru. And then there will be something called only Laghu. Then there will be something in between where three Gurus and 1 Laghu, 2 Gurus, 2 Laghu, and you can compute it. So I want to ask the number how many chandas are there with all 4 Gurus, 3 Gurus, 2 Gurus, 1 Guru. This is exactly the binomial coefficient. This is just expanding. This is exactly equivalent to that. Correct? The third one is Swankhan, is how many patterns are there? I mean, you keep saying all of this. How many total patterns are there? 2 to the power n, right? What is the big deal about it? How do you compute 2 to the power n? I give n a very large number. So will you multiply that many times? If I ask you to do 2 to the power 20 without calculator, pen and paper, how will you do it? Will you say take 2 multiply 2? Go, ho gaya. 2 multiply this multiplied by another 2. Will you keep on doing like this? You can keep on doing like this. But that's not efficient. What is the efficient way of doing this? Let's say 2 to the power 20, right? So if you can compute 2 to the power 10, you can multiply it with itself. How do you compute 2 to the power 10? Compute 2 to the power 5. How do you compute 2 to the power 5? 2 to the power 2.5. No, you can't do 2 to the power 2.5. So you say 2 to the power 4 times 2. So you say this is essentially logarithmic algorithm. Again, that's so the question here is efficiency of doing. And then the Advaita is that, well, fine, I want all patterns up to length n. So 2 to the power 1 because of length 1, 2 to the power 2 of length 2, etc. This is a geometric progression. The direct answer is given, but this is a geometric progression. And in fact, Narayan Pandit has got elaborate examples and these things on how to compute this geometric sum for any general, like A, R, what we do, right? Starting with the A and the term is R and whatever, all of this. So let me go quickly over some of the algorithms. It's actually interesting algorithm. Maybe instead of the algorithm, this thing what it starts is that I start with this, okay, 0, 0, 0. So first one is Guru, Guru, Guru. Then I go to next row, take the leftmost 0 and change it to 1. Okay? Change it to 1 and copy everything that is there on the right. Fine. Then make everything to this left as 0. So here I take the leftmost 0, make it 1 and copy everything. Now there is nothing on the left of it, so I don't worry. So the next pattern that I get is 1 0 0. Okay. Next what do I do? I take the first 0, change it to 1. So it becomes 1 1 0, but I am not done. Make everything to its left as 0. So I get 1 1 0, but I am not done. I have to, this 1 becomes 0. So I get 0 1 0. Okay. Next you take 1 1 0, right? Just the leftmost 0. You keep doing this. So it first of all, for computer science students, this is a very nice exercise. Show that this algorithm is correct and it will generate all things. And it is efficient, also meaning it actually does only 2 to the power n steps, whatever is needed. And it is correct. This is an exercise that we should be doing. But you do this, so you get these numbers. So the numbers that you get is 0 0 0 1 0 0 0 1 0 1 1 0. This doesn't sound like our normal enumeration of binary numbers, right? So what is happening? Can anyone see a clue there?
It's the indices are reversed.
Yeah, this is reversed. So if you read this 1 0 0 as 0 0 1, then you get our familiar pattern. So it's just, I mean, if you now change this left to right and right to left, you get it. So it's not a big deal, right? Right? Fine? So this is when read from right to left. Okay. Now the question is, so this is my rank order that I get. Okay. The next algorithm says, okay, there is another algorithm for this, which is probably for the prosody, which is probably the more easy. You just write 0 1 0 1 0 1 0 1, then you write 0 0 1 1 0 0 1 1, then you write 0 0 0 0 1 1 1 1. So number of columns is n, start from the leftmost, write alternate 0 1, then alternate 0 0 0 1, 0 0 0. This is even easier, right? Except that there is an assumption that you can keep on doing it till how far and all of this. Right? Okay, but now going to this Nashta method. So this is a decimal to binary conversion. So what is the standard algorithm now for decimal to binary conversion? This is first year, first course for computer science, right? Decimal to binary conversion, how do you do it? Keep dividing by 2, right? Essentially keep dividing by 2, keep collecting the remainders and put them in the reverse order. Yes, it's important. So now you see this. So you start with this. If q is even, you write 1. If q is odd, you write 0. Remember, this guru lagu is the other way around actually. Yeah, right? And you do exactly this thing. We keep dividing by 0. Keep dividing by 2. This is exactly the algorithm. So if you take length 3, rank 5. So you do this. So you start we start with q equal to 5, right? So this is odd. So you write down 0 and you get the next one as 3. This is odd, so you write down this as 2. Then this is even, this is even, so you write down 1 and you get 1 and then you are done. You want length 3. You stop. So what is the number that you get? For this rank 5, we get 0 0 1. What is happening? 5 is 0 0. Okay, you reverse it, you get 1 0 0. That's still not 5. What is wrong? So all this is wrong, right? This is because of this modern computer science trick. What is a modern computer science trick? How do we start enumerating numbers? From 0. But normal people, not to say we are abnormal, but I'm just saying, in general, normal people, when you say rank, start with 1. So 1 0 0. If you take in the computer science sense, what is its rank? Add plus 1, right? It's 5th. Actually, its rank is 5th. Because you start from 0. So 0, 1, 2, 3, 4. Right? Correct? So that is exactly what does. So his algorithm actually gives you directly this. So in some sense, you may say this is a better algorithm because computer science 0 is used because of ease of calculation. It's much easier if you do it this way. But this is not very difficult either. In fact, complexity wise and all of this wise, I think this is the same thing, right? Fine? Okay. And this is consistent, of course, as long as the opposite algorithm works. So, so if you give 0, 0, 1, it should give you back 5. You should not now say this is 4 or 1 or something. So how is that Uddishta algorithm does? It's exactly the same thing. The other way around, you multiply by 2 again. So given a bit pattern, how do we get the decimal number? Standard form. Keep multiplying by 2, right? The last one. Start from the least significant bit, the last bit, start multiplying by 2, keep multiplying by 2. Right? So that's exactly what it is being done. So you start 2r, and I mean you r equal to 1. So this is 1, so you just multiply by 2. Then this is 0, you multiply by 2 minus 1. Again, because of this, it's not just multiplying by 1, because of the odd even, the 0 and 1 you have to take care of it. And you get 5. Exactly the same thing. There is an even simpler method for binary to decimal conversion. What is it? You don't have to keep multiplying by 2. So this thing, if I write 4 and 2 in decimal, what is the total value of this? 42. Why 42? Because 4 into 10. So 2 into 10 to the power 0 plus 4 into 10. If I write 142, 1 into 100, right? So because it's powers of 10. Same thing is followed for the binary system. So if I write say 101, what do you do? Last one into 2 to the power 0, 1. The second 0 by 2, the 1 by 4. So you add them up. That's another way of getting this. That's another algorithm. Exactly the same algorithm. So you write down this and you write down the place values. Remember, this is right to left. So you write it the other way around. Then what you do is anything that is 0 you ignore. That's why, because it's multiplying by 0, right? So you add this up, you get 4. So you ignore this, you get 4. Remember, ranks in Pingala system is 1 plus. So plus 1. Fine. So this you get plus 1. Fine? Okay, this is a modern binary to decimal method. And now I will come to the more interesting things. This is called the Lagha Kriya. This is the binomial coefficient, right? And the binomial coefficient directly uses this rule, of course, without stating it in this format. That NCR minus 1 plus NR is equal to N plus 1 CR. So what it does, again, let's start with this example. So you write down 1, then you write down 1 at 2 ends. Then what do? You write down 1 at 2 ends, of course. So you write a 1 here, 1 here. What is the number you put in here? To add these two. 1 to 1. So what is the next thing? 1, 1. Then this one is 3, 3. That's exactly the method. Keep doing this. That's what happens actually. I mean, you can show that this is actually what is being done in a binomial coefficient. That is the method. So this is, so that means if you take this length n4, what does this solve? That one chanda has exactly 0 guru, which means 4 lagu. 4 of them has got 1 guru, which means 3 lagu. 6 of them has got 2 guru and 2 lagu, and so on and so forth. Right? And this should be easy to see. One chanda which has got exactly 0 guru is all lagu, 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 lagu. And the 4 which are there is start with guru, lagu, 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 then lagu, guru, lagu, 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 guru, lagu, and lagu, 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 guru. Right? So on. So you want to enumerate this. This is Pascal's triangle. This is actually Varnameru or Varnaprastha. Much earlier than Pascal. But then there are lots of historic reasons why we call it a Pascal's triangle. Since I am being recorded, I will just stop there. Okay. Direct answer for the Sankhan algorithm, how many patterns? 2 to the power n. How do you compute 2 to the power n? We have already discussed this. So essentially, let's see. So again, just start with this example. So it's 10, right? So I want to compute 2 to the power 10. I don't want to do 10 or I don't want to do 9 multiplications, right? So I do divide by 2. I get 5. And I write down 2. Then I divide. So this is odd. So this is even, therefore I write down 2. This is odd. I write down 0 and I take 5 minus 1. And I keep doing this till I hit 0. Now I proceed in the backward order. What is it? I start with 1. Right? Then what do I do? This is 0. Then what do I do? If it is 0, I multiply by 2. I get 2. If it is 2, I square it. This. So how many? 1, 2, 3, 4, 5. 5 computations instead of 9 computations. Right? So essentially writing it down this way, this is the logarithmic number. Correct? All right. So maybe, and the last one is direct answer. It's given just adding them up and just to compute it. Maybe I'll go to some more interesting things. Okay. So the Matra Chanda. Now I ask you this question: how many total chandas can be made so that it adds up to a total matra of m? It is not a very trivial question. It is not a hard question, but it's not a very trivial question. So let's try. So if the matra adds up to 1, how many total possibilities are there? 1. Only one lahu, we cannot do. For 2, what are the total possibilities? How many 2? What are the 2s? Lahu or 1 guru. For 3, right? What is this? Lahu guru, guru lahu, lahu. Right? So it's 1, 2, 3. How do you get at a principal way of doing it? If I start asking 4, this is the interesting part. There are 3 possibilities, right? Now think of how did you arrive at 3? So your target point is 3, right? How can you go to 3? By the last letter, maybe either a lahu or a guru. If the last letter is lahu, that means you are already at 2, then you added 1 lahu. Versus the last letter is guru, meaning you were already at 3 minus 2, 1, and you added. So how many ways can you do it? Total number of ways you have reached 2 plus the total number of ways you have reached 1. Correct? Right? This is even. What is this? What is this series? Fibonacci. Fibonacci was in Pisa in around roughly 1000 years back. Correct? This is Fibonacci series. These are Hemachandra numbers, Virahanka series, etc. Pingala doesn't talk about this algorithm. You see this. And this is by induction. The proof is by induction. The whole idea how you can compute this is from induction. That it becomes very hard to enumerate, right, after a while. But you can always break it down to these 2 cases, right? The last one is lahu or the last one is guru. And you assume that the previous 2 cases are solved. Okay? So then, now I want to enumerate all of them. I have got the number. I want to enumerate. Again, it's not as trivial as binary number thing. In fact, there is a meru for all of this. So, and I want to do this counting the number of chandas having a particular matra length with 1 guru, 2 guru, all of this. I want this. So that is the analogous, the equivalent of binomial coefficient, but for matra. So the total sum is same, not the individual things. So the lengths vary, correct? And you still have to add them up. That is called matra meru. And again, there is a very nice, elegant algorithm for doing this, writing down one by one. And then I'll finish with this permutation of n numbers. So here is actually what is being done. So Vishnu, the god, has got 4 hands and he has got 4 kinds of astras, right? How many possible sculptures, how many possible figures can you make? One hand, one astra. How many can you make it? Huh? How many? 24. This is the permutation, right? This is factorial 4. This is actually called Chaturvinshati Keshavanama. So when we say this is a Madhava Murti, this is a Vasudeva Murti and all of this is if you are very, very strict, you have to ensure that they have got the right astra in the right hand. Otherwise you just cannot use the name Keshava and Rishikesha and Vishnu and all of this. I am told I have not gone to any of these two temples, but I am told that this Chennakeshava temple and this Venkateshwara temple has got the sculptures, the figures for all 24. So if anyone has gone there, you may have noted this, may not have noted this. Next time you go, please send me pictures of these 24 pictures. Because the pictures that I got from the internet, first of all, I'm not sure whether they're actual pictures. Second, it's very hard, but you can see this. This is Gada, this is Chakra, this is Shankha, this is Padma. So this and this is Gada, then they think Shankha, then Chakra, then Padma. So we never noticed this. In fact, I also did not notice this ever before studying this. But there is this Chaturvimshati Keshavana. 24. Thank you all. So that's all that I wanted to say. So it is one of the most beautiful sciences. It is a science. There are lots of algorithmic things, lots of things to be proven. One of the most beautiful things. It combines this art, and here is the Chandagyanam website. And just if you are wondering how did I write all this Sanskrit and IAST, all of this is just to dazzle you even further. Dhanyavada to all of you in your own script and language. Thank you all.